Extracting data from pre-existing documents is a key requirement for certain cutting-edge AI applications today. However, many digital documents, especially those obtained by a scanner, do not contain digital text that can be simply copied by a computer. In such instances, we rely on OCR, which is the equivalent of a computer visually looking at and identifying text. And while every major cloud services vendor provides several OCR services, these can get expensive over time, especially for the more feature-rich and capable service offerings. There's also the inherent risk of data loss and theft when transmitting private, sensitive data over the public internet, leading to ransomware demands from cybercriminals and costly lawsuits for businesses. LARS mitigates these risks via two fully local AI-OCR options, and we can head to the settings to switch between them. Here, we've set up for local OCR, and the Cosmos AI-OCR model has been selected from the drop-down Services menu. The service is fully configured and ready to go, and so we can proceed to the demo. To add a new document to the LARS backend RAG engine, we simply make use of the Upload button, and once done, we can proceed to ask our question. As the response generation completes, we see the LARS citation system at work, with the document browser, text highlighting, and the names and specific page numbers of relevant reference documents at the end. Additionally, we also see the language model itself referencing specific source material. A side-by-side comparison of the uploaded PDF document and the Cosmos OCR extracted text reveals a detailed, accurate, page-wise text extract. This has been achieved offline on a single GPU. And to demonstrate this, let me bring up monitoring software, which has registered clear GPU utilization spikes every time OCR was performed by Cosmos. There are 14 spikes corresponding to the number of processed pages, with the second graph showcasing increased memory usage at these times. Our custom-developed, locally deployable and offline Cosmos service is extremely powerful, returning detailed bounding box coordinates and text for any document format. Developers can leverage these powerful APIs to obtain fully parsed text, along with a wealth of OCR result data. For multi-page documents, a streaming feature is available to provide OCR results for each page as soon as it's scanned. Challenging scenarios such as offset, misaligned scans can also be handled by simply specifying a tolerance threshold. Cosmos is but one of the local OCR options in LARS, so let's switch over to a powerful alternative, one that can leverage a single model for both chat and OCR, rather than having a separate model loaded up alongside. We select the pre-configured Vision OCR service and proceed to swap the presently loaded large language model for Meta's Llama 3.2 Vision, selecting it from the drop-down and toggling Vision to Yes. Our Waitress LLM server now proceeds to safely switch models, following which we can proceed to load documents as before and pose our question. The Vision model generates a complete response, and we've thus successfully utilized a single, locally deployed model for the entirety of the document loading and Q&A pipeline. When reviewing the OCR results, we can see that an additional challenge has been successfully addressed: extracting data from tables while preserving meaningful context. Although tables are straightforward for humans to interpret, machines often struggle, as cell data can lose meaning outside of its row and column structure. To overcome this, the Vision model includes table headers and positional data wherever possible, thanks to our precisely tuned Vision OCR prompt on the back end, working seamlessly behind the scenes for the user.